Hey everyone, so for this week you have two separate videos talking about two separate topics. Both of them are pretty short, so we're not going to spend too much time on these, but you do have two videos this week, just FYI. So in today's lecture, we're going to talk about basic chemistry, matter and energy, atomic structure, and chemical bonds and reactions. We're not going to spend too much time on this. Just very briefly, just because this is in a chemistry class, but you do need to know the basics if you are asked. So getting to basic chemistry. So matter is anything that has weight and takes up space. For example, you have oil, wood, rocks, and you. You are a living organism. So matter can be solid, liquid, gas, or even plasma, and we have examples of all of those over here. So matter is composed of elements, which are unique substances that cannot be broken down by a chemical reaction. So these elements include oxygen, carbon, aluminum, gold, and nitrogen. Most of the ones that we focus on in biology are oxygen, carbon, nitrogen, hydrogen, and phosphorus. Those are the four that we normally focus on the most. I'm sure you know what this is. It's the periodic table of elements. We're not going to get into, I'm not going to ask you to memorize this or anything, but you do need to know how to break down what each box looks like and what they have in them. So each square contains information about one specific element. So this is the square for carbon. It has its element name written up at the top. In most cases, this is how it's oriented, so we'll just talk about it this way. So we've got the element name at the top, the atomic numbers, that's how many protons and electrons there should be if it is a pure element. The symbol, which is a 1 to 2 letter abbreviation of the name. Most of the time, sometimes it's odd just because of the scientific name and things like that nature, but for carbon it's just C. And then we have the atomic mass. So that's the mass that includes all of the elements' isotopes. So it's the number of protons, neutrons, electrons, it's their weight of all of those. Some elements are still being discovered. We still add elements to the periodic table periodically as they're found. Okay, you can see glucose here at the top. We have a DNA strand, and then there's serotonin. So most living things are made up of about 17 to 25 elements. Like I told you, most of your body is composed of carbon, oxygen, hydrogen, nitrogen, and phosphorus. So you can see in this glucose molecule, we have carbon, hydrogen, and oxygen. In your DNA, you have carbon, nitrogen, and phosphorus. And then in serotonin, there's also carbon, hydrogen, and I believe oxygen. 4 of these elements make up 96% of all living things. Like I've been saying, carbon, oxygen, hydrogen, and nitrogen. A lot of times we get into phosphorus. It's not as abundant in your body, but like I said, it does make up the backbone of DNA. So getting into matter and energy. So 2 main types of energy exist. We have potential energy, which is what is stored. And then we have kinetic energy, or the energy of motion. So her pulling the string back on this bow is potential energy. There's a ton of potential energy here, but as soon as she releases it, that is kinetic energy. And just like this snowboarder at the very top of the mountain, he had potential energy, and then as he's going down, there is kinetic energy. So we have chemical energy, which is stored in bonds in chemical structures. We have electrical energy, which results from particles moving in and out. There's a high concentration here, so it's going to make it want to go to the outside to get a equilibrium going, but we'll talk about that in later chapters. But this can cause an electrical energy to happen. We have mechanical energy, which is directly involved with moving. And then you have radiant or electromagnetic energy, which travels in waves, such as heat, light, ultraviolet rays, and X-rays. Energy can be transformed from one type to another. So chemical reactions tend to give off heat. So you have radiant energy here, it goes to chemical energy. You eat, that's chemical, and it turns into energy, which allows you to move. All that energy is transformed. Energy cannot be created or destroyed, but it can be manipulated and transformed into something else. All right, getting into atomic structure. So each element is composed of building blocks called atoms. So here is an atom. It is made up of protons, neutrons, and electrons. I'll just put that, but protons carry a positive charge, neutrons have a neutral charge, and electrons carry a negative charge. Protons and neutrons are in the nucleus, or the center of the atom, while electrons stay out here in what we call the electron cloud. So each particle varies in mass. Each particle changes in mass and density and things of that nature. Sorry, I pressed the button too quickly. But getting into this, the protons and neutrons are located in the nucleus. Electrons orbit around the nucleus in electron clouds, and electron clouds have different levels called orbitals. So there will be different electron clouds going out here. So you can have up to 8 coming out, and they'll go out further and further. So orbitals are represented here as circles, but in reality they're a complex 3D shape. So like I say, they'll come out here, but they're actually a 3D shape, and they're kind of cool. Maybe we'll find a video on it, but so they are spherical or figure 8, or they can be even more complex and have other things going on. So what happens if you lose or gain any of your subatomic particles? So if you lose or gain protons, you have changed your element. It is no longer carbon or oxygen or anything like that, because remember we talked about the atomic number. So if it gains or loses a proton, it changes your atomic number, which essentially changes your element that you have. If you lose or gain neutrons, you get an isotope that will change your atomic mass. And so that's when you see different isotopes, like carbon-13, carbon-14, and that's just talking about the number of neutrons that are available. And if you lose or gain electrons, that's when we get into ions. So anions are negatively charged ions, so that means that they gained an electron, because remember, electrons are negative. So if they gain an electron, they become negatively charged. And cations are positively charged, because if they lose that negative charge, they then become positive. We're going to skip that. So we got the nucleus, the electron cloud. It tells you to draw everything out, but we're going to skip this pretty much. All right, so when atoms interact, their electrons are doing all the work. Electrons are the particles that are involved in chemical reactions and bonding. Valence electrons outside of the orbital electrons are the ones that bond. So the ones on the very last electron cloud are the ones that do the bonding. So the ones in the center, if they have multiple rings, do not do anything. So getting into chemical bonds and reactions. So chemical bonds are chemical states where atoms gain, lose, or share electrons. So we have ionic bonds, covalent bonds, and hydrogen bonds. Ionic bonds are when one atom transfers an electron. So you can see this one up at the top. It's actually talking about giving its electron to the other one. So that is an ionic bond. So the atom that gives away its electron will become positive. while the one that gains the electron will become negative. And opposites attract. So getting into covalent bonds down here at the bottom, it's where they're actually going to share. So they'll swap back and forth. Each covalent bond shares 2 electrons. Oh, so you can see that here. So we have a single bond going on right here. They're sharing those electrons right here. And then we have double bonds and triple bonds. That means that they are sharing more electrons. So one bond is between one single bond. So we have 2 electrons connected right here. The double bonds, then we have 2 electrons connected. And triple bonds is when you have 3 bonds. Getting on to hydrogen bonds, they're an attractive force between electropositive hydrogens and one molecule and an electronegative atom of another one. So we get these when we talk about water. So you can see right here, this is water, here is your oxygen, here are your hydrogens. So the negative end of one molecule attracts to the positive end of another one. This is again the opposites attract rule. So small atoms like oxygen are electron hungry and attract electrons strongly, which is called electronegativity. Hydrogen, on the other hand, has a low electron attracting capability, and it is electropositive. This is why hydrogen bonds can exist between polar molecules like water. So the negativity, the electronegativity in oxygen, craving more electrons, attracts the positively charged or electropositive hydrogen. That hydrogen will share their one electron with oxygen and bind together. Come on. Oh, I'm messing. Oh well. All right. Chemical bonds either make or break, or chemical reactions either make or break chemical bonds. We write a chemical equation in a particular way, show what we had versus what we got. This is called a chemical equation. So if you have 2 molecules of H2 plus an oxygen, call this an oxygen ion. It's not pure oxygen because you have 2 of them together. So those are your reactants. That's going to be on the left-hand side of your equation. That's what we started with. So when we combine these 2 things together, we have a chemical reaction, and you get 2 molecules of water. And these are your products. The products will always be on the right-hand side of the equation. So just like I said, reactants are what you start out with. The arrow means yielding, so this is what we are making. And then the products are what you end up with. The numbers before the reactants are the coefficients, and they will tell you how many molecules you end up with. So like I said, you had 2 hydrogen ions over here. You only had 1 oxygen. There's not a number in front of it. You just assume that it's 1. So we have 1 oxygen ion over here, and we get 2 water molecules. Are you going to play? Okay, it wasn't going to play, which is cool. So the next lecture, we're going to talk about water and carbon. So I will see you guys over there.